So what we got here is a disk attached to an elastic cord. And so it's given an initial velocity of 5 meters per second. And then immediately the cord will begin pulling in. But it starts with a 0 acceleration in the r direction. And then after it's pulled in a little bit, it'll have velocity in the r direction, which it's saying the rate of shortening of the elastic cord. But it'll also have tangential velocity, and then the resultant velocity is going to be the tangential velocity square root with the radial velocity. So let's start out by finding the velocity at the end, and we'll do that using conservation of energy. So we got 1/2 mv squared plus 1/2 kx squared equals 1/2 mv squared final plus 1/2 kx squared final. So this is the initial kinetic, initial potential, initial kinetic, and final potential, or final kinetic, final potential. So we got 1/2, the mass is 5, the velocity is 5, plus 1/2, 200, and x here is going to be the difference between r, 1.5, and the unstretched length, so that distance is 1. And then we get 1/2, 5, velocity final we don't know, plus 1/2, 200, and the final stretch is going to be 1.2 minus 5.5, which is 0.7 squared. So we can solve this. The only thing not known there is v final, so v final is equal to 6.74 feet per second. So if we look at that, then there's the disk. That velocity is going to be at an angle. Here's the radial, and then that's the velocity, 6.74. We need the radial velocity and the tangential velocity, and that equals that. The tangential velocity is, or the radial velocity is the rate of shortening. So we're going to use conservation of momentum, of angular momentum, to find the tangential velocity. So using that, we can do m r v, conservation of angular momentum, initial, equals m v final r final. So that's 5. Oh, the masses cancel out. And so the radius, the velocity, starts out at 5, and r starts out at 1.5. And the velocity final we're trying to find, and r ends up at 1.2. So the velocity final is equal to 6.25. That's final, that's in the tangential direction. So now we have this one is 6.25, and this is what we're trying to find out, which is the VR. So VR is equal to the square root of 6.74 squared minus 6.25 squared, and that equals 2.53 meters per second.